Thursday the 11th of July, and the sun, as you can see, is still glaring down at me, although it may not be glaring at thee. Basically setting up the scope for about 2 days till the third quarter on the moon. And the idea here will be I'll set something like the 6-inch, real 6-inch settings. We'll do 16 flood, and we will do 32 auto gain control decibels. And we will be exploring open clusters this evening to give folks with a small scope, and maybe mix in some globulars. Yeah, let's do some clusters tonight. So those with a 6-inch scope, that a very excellent beginning type scope. This is a nice Newtonian 6-inch reflector. Well, get an idea of what you might be able to make out. Of course, I'll be doing it through a 6-inch scope, but it'll be ably amplified in its presence by way of a CCD imaging system known as the Revolution 2. And you will be seeing the images up on this screen as we have done earlier, where I did a 9-inch scope equivalent exploration of globulars. So we will do clusters tonight. We will do brightish objects, brightish studies, including the Ring Nebula, etc., etc. Anything that someone who has a smallish scope, a 6-inch, like I said, typically a Newtonian reflector, would want to go out and see. Now, the only hampering we're going to have is that moon up there. I don't know if you can see it. I'm going to zoom in a little bit. I may capture it a little bit later on. No, we are not picking it up because we have this camera set for imaging the TFT monitor screen. Anyway, we'll catch you later, probably around 10:15. Okay, let us begin. It's about 10:05 in the evening on the 11th of July. I want you to notice the settings. These are my classic settings for a 6-inch scope. I misrepresented it the other night. 6-inch scope settings, in my estimation, are a shutter speed of 16 flood and an AGC max of 36, not 42. If you push it to 42, let's get a sense of how it will change. So that's 8. Back to 16. Let's go to 42. Okay, we'll give it a chance to develop. My experiences have been we add about a half a magnitude to the intensity of a study if we go from 36 decibels to 42, because when you go up a full 8 decibels, you basically get about a 0.75 or 0.8 magnitude increase. What we want to do tonight is we want to explore a few deep sky studies along the Milky Way operating at 6-inch settings, and you notice just then how we lost a little luminosity, but we're still getting quite a nice view here in Messier 57, the Ring Nebula. I do want to point out this little star right here. I know it's a 13th magnitude star, 13.1. I have seen it through a 6-inch scope on a decent night. We are getting a view of it, so that's a nice baseline. Let me go ahead and save out these. Well, don't do that yet. Save out these settings, and we will have a better look at the ring without having the presence of the lettering or font on the screen. And there you can see it right there. We're seeing some bluish hints to it. I boosted the screen brightness, and I may do it again because as you drop down on the exposure time, the screen brightness changes visibly. So let's go ahead and bump that up to 15 so we don't get as much of an effect across the screen from being bright at the top to darker bar at the bottom. I will centralize this up. We will not have a look, for instance, tonight at Messier 13 or Messier 92 22. Those globular clusters, not because they're globular clusters, but because they're being partially blocked by the roof try of Penty, the observatory. However, we will have a look at 56 and 22, and then we will go to maybe NGC 6100 and discover adventitious studies that are in the Gemini 2 database using these 6-inch settings. The moon is pretty decently to the south and the west. The sky overhead has a slight amount of color in it, but I was inspecting the sky with the moon present, and as long as we stay with the scope pointed on the right ascension azimuth to the east, we shouldn't have any problem with luminosity from the moon obscuring the views, not like the other night where we had smoke from fires. It seems to have cleared up during the course of the day. M57, the Ring Nebula. Nice look. One thing I want to point out is how quickly studies develop at 16 flood. I started the camera as soon as the Losbandy navigated to Messier 56. Globular cluster in Lyra, almost on the border with Cygnus the Swan. And there you go. We are seeing it. There's a peppering of stars that are resolved, plus the core condensation. The data on Messier 56 is as follows. It's a fairly distant globular cluster. It's in Lyra, magnitude 8.3, 5 arc minutes in size, some 32,900 light years distant, right ascension 35, declination 301105. But I do want to point out, as in the previous real-time imaging series, which featured globular clusters at nominally a 9-inch aperture setting, that oftentimes the data about distance and size is incorrect, and that you do have to go online, but I gave some clues out as to how you can compare any globular cluster to Messier 4, which will be our next look this evening, so you can get a sense of how accurate it is. Most globular clusters range from about 50 to 250 light years in diameter. Their range is from about 7,000 to about 55 or 56,000 light years distant. Most of them have a class of 6, which means the brightest stars are roughly about 6 magnitudes fainter than the total cluster brightness. There's no class rating for M56 in the Messier catalog, but we assume it's probably mid-range, so its brightest stars are probably magnitude, well, I've seen them before in a 6-inch, and we are seeing some resolved. So I would say the brightest stars are somewhere around magnitude 13, which would mean a delta of 6.5 magnitudes, which means the cluster is probably fairly condensed. It's probably a class 3 or a class 4 globular cluster, but who knows? Look it up for yourself. There is a lot of individual variation. These are just guidelines. Here we can watch another globular cluster forming. I was going to take you to Messier 4, but it's post-culminatory. The scope wanted to do an equatorial flip, so instead we are having a look at Messier 22. I have seen it through a 6-inch scope. There are numerous stars resolvable. The brightest are probably around magnitude 12.8. I will give you the data on Messier 22. I do not know the NGC designation, so I can't give you a full set of data. And then I'm going to synchronize the scope to it, because we're going to begin probably somewhere around NGC 6300 again this evening, in order to adventitiously turn up various studies of interest throughout the evening. Once again, we have achieved sky dark. It's 10:15 and 40 seconds right now in the evening. Data on Messier 22 is forthcoming. Messier-22 globular cluster in Sagittarius, magnitude 5.2, 24 arc minutes in size, so almost as large as Messier-13, which is about, or Messier-4, which is about 26, and about the same size as Messier-13. 22 and Messier-22 is 10,400 light years distant. There's no class information of the Messier handset. We're at right ascension 1836.24, declination minus 23, 54.12, and because we're going to be operating at 6-inch settings this evening, I don't think I'll go any further south than minus 30 degrees. We have a lot to explore, however, and we will proceed straight away. Okay, the scope just settled in on NGC 6304, a globular cluster in Ophiuchus. This will give you an idea of a similarly bright globular cluster that's similar to Messier 56, but was not in the catalog, I do not believe. I'll see if it does have a Messier number. But you will see that we're losing quite a bit. Although it's got a brightish core, because we're fairly south of the celestial equator, we are not going to get quite as good a view as we did of Messier 56. So let me call it the data as you watch it form on the screen right about there. Remember, these are roughly 6-inch settings, so we're not going to get the kind of deep views that we might otherwise get. NGC 6304, globular cluster Ophiuchus, magnitude 8.4, 3.8 arc minutes. The brightest star is at magnitude 14.2. We should not expect to see any resolution. All we might see is some pixelation. It is a class 6 that is 20,000 light years distant. Notice that delta between the total magnitude. It's about 6, and this is a class 6, so that falls into pretty good alignment with our rule of thumb rules of globular clusters. We're at right ascension 17, 14, 32, and a declination almost 30, minus 29, 27, 43, and that's why I selected it, because it was above minus 30 degrees, which means that it's culminating right now, so it's only 15 degrees above what would be the horizon if there weren't mountains to the south of the John Day Valley. Okay, we're going to have a look at NGC 6309, a planetary in Ophiuchus. Unfortunately, it'll probably turn out to be fairly small, but it is in decent sky position, or at least it meets my basic parameters. Planetary nebulae are kind of hard to pick out because the stars, they can look, if they're in the less than 10 arc seconds in size, they basically look like stars, but this one's a little larger. NGC 6309, planetary Ophiuchus, is magnitude 11.6, 20 by 10 arc seconds, with a central star of magnitude 16.3. Fairly distant, 8,900 light years. It's at RA 171404, declination minus 12, 5437. I do believe we're seeing the planetary right about there, but there's no guarantees on that. Okay, I originally had intended to just do clusters, but you know what? There's some galaxies. I'd like to probe the limits for a 6-inch scope in terms of galaxies at the eyepiece. Do not believe we're going to see much beyond a magnitude 12 galaxy. This one is a little fainter than that. Let's determine. It's NGC 6314. I'll give you the data, see if you can formulate on the screen. If it actually formulates, I would think that we're probably getting a little better views than we would otherwise with a 6-inch scope. However, I would point out that at magnitude 12.9, we are unlikely to get a hint of this galaxy, and I won't be able to tell until tomorrow. The scope is at plus 23, 16, 13 declination. There is no obstruction of the aperture at all. NGC 6314, Galaxy and Hercules, magnitude 12.9, 1.6 by 0.7 arc minutes, so it's roughly a 13th magnitude average surface brightness. Spiral, the lowercase a, fairly distant, 303 million light years, so intrinsically about the size of the Great Andromeda Galaxy, removed by a factor of at least 100. Right ascension 17, 12, 38, declination 23, 16, 13. Maybe, just maybe, we will see something on the screen. I'll look at it tomorrow and give you my impressions in captions. NGC 6314. Oh, let's watch this one develop. NGC 6316. Calling up the data. It's a race between me and it appearing on the screen. Shouldn't expect it to take more than 10 seconds to formulate. And I am seeing the cluster right about there in the expected location. As you see, 6316, globular cluster Ophiuchus, brighter than Messier 56, magnitude 8.1, bit smaller, 4.9 arc minutes, with brightest stars of magnitude 16. It's 37,000 light years distant, and this is a class 3. And if you look at the delta between the brightest stars, this is 8 magnitudes, which is a little higher delta than I would expect. I figure even a class 1 would have a delta of about 7.5. So, but anyway, the cluster is quite apparent. We're at 17, 16, 37 right ascension, and a declination of minus 2808. 22. There is our view. NGC 6325 should be a little beyond the capabilities of the scope. I have seen the intergalactic wanderer, and I believe it's around magnitude 10.4, but it was well overhead. We are looking deep south, and if we're going to get a view of NGC 6325 globular cluster, I would be very surprised, and I would have to consider the idea that maybe these settings and the performance of the scope is a little underestimated. You can look on this and see if you can make out a globular cluster. I do not expect to see it, maybe just a glimmering. NGC 6325, globular cluster Ophiuchus, magnitude 10.2. If overhead, I would expect to resolve it. 1.6 arc minutes with stars. The brightest stars are 14.7. Now that's kind of vague because that means it's only got about a 4.5 magnitude difference, although this is a class 4, 31,000 light years distant, which gives me pause as to the accuracy of the data that we are seeing on the handset. Right ascension 17, 17, 58, declination 23, 45, 57. Here we should see developing a Messier-class globular cluster, NGC 6333. Let me look it up. And the cluster is quite apparent. It looks like there's some resolution of stars. It is a Messier class, Messier 9, globular cluster Ophiuchus, magnitude 7.9, 5.5 arc minutes. Its brightest stars are magnitude 13.5. I do not expect to see them. We are getting better performance than I would expect. It's a class 8 with a delta of about 5.5, so that makes sense. 27,000 light years distant. RA 17, 19, 11, declination 18, 30, 58. The fact that we're resolving this cluster, well, it is at minus 18 degrees. Brightest star is magnitude 13.5. That's suspect. Either I got my settings wrong, and once again, I may be overexposing. Maybe I have to reduce it, but I'm going to stay with this for the time being. Still, that's what this evening's about, is to give roughly 6-inch views and validate the set points for future reference. NGC 6333. Once again, I'm initiating the camera as soon as we stabilize the mount and go to. This is NGC 6342, another globular cluster in Ophiuchus. I'll give you the data on that. Yeah, there's faint wisps of the cluster right there. NGC 6342, globular cluster Ophiuchus, faint, magnitude 9.5, 3 arc minutes in size, with the brightest stars of magnitude 15. No way we would resolve those. There is some speckling on the screen, and let's just assume that when it looks like there's kind of a star, when there really shouldn't be any present, this is my hypothesis, it's basically that there's a group of stars whose magnitudes are combining together to give some kind of sense of resolution where it's not really occurring. This is a class 4, 30,000 light years distant. With magnitude 15, that means it's 5.5 magnitudes fainter on the brightest stars in the cluster itself. This is a class 4. We would expect it to be more like 6.5, but that's okay. We just use these as a rough sense to give us more confidence that the data we're seeing on the screen or elsewhere is fairly accurate. NGC 6342. Okay, once again, initializing the camera on stabilization for NGC 6355 this time. NGC 6355, globular cluster Ophiuchus, magnitude 8.6, 6.1 arc minutes in size, 23,000 light years distant. At some point I should be able to just rattle off a rough size of the clusters, but as I've done in the past with galaxies, but I really haven't gotten myself completely acclimated to that. We're at right ascension 1723.58, declination minus 2621.10 for NGC 6355. A little delay on initializing the camera this time. For NGC 6356, globular cluster Ophiuchus, magnitude 8.2, 3.5 arc minutes, brightest stars magnitude 15. So we're talking about 6.8 magnitudes, and that makes sense because it's a class Roman numeral 2 of 12. Distant 54,000 light years, right ascension 1723.34, declination minus 1748.51, and at magnitude 8.2 you think this would have been discovered by Charles Messier and Associates, but that was not the case. Okay, once again initializing the camera on stabilization for NGC, this time 6366. Another globular cluster. Fairly bright as I well, I don't know, maybe the data, let's see what the data has to say. Looking at it, it's got to be it's a very faint globular cluster you'd expect in Ophiuchus, NGC 6366, magnitude 9.5, 5.8 arc minutes in size. The brightest stars are magnitude 13.6. That basically tells you only 4 magnitudes delta between the collective and the brightest star magnitude, and that makes sense because this is a class 11, a mere 12,000 light years distant. Not much going on with this particular globular cluster. Not really making out. I think the other night we had the same problem with this cluster that really wasn't revealing itself very well. We're at right ascension 1727.44, declination minus 504.35. Okay, here we have a larger, brighter galaxy. It's an Ophiuchus. Let me get the data on it. NGC 6368. Okay, I'm looking at the screen. There is kind of a faintish glow right there. That would be the core. This is NGC 6368 galaxy in Ophiuchus, magnitude 12.3, 3.8 by 1 arc minute. That core would roughly be, because this is a spiral class B, twice removed from a lenticular, 123 million light years distant, puts it at probably about 125,000 light years in diameter. It's a magnitude 12.3 galaxy, and if you add 0.8, because half the light is typically found in terms of spiral galaxies in the core, we'd be seeing something around magnitude 13.1, if indeed we are seeing the faint core of that galaxy at the tip of my finger. And that would kind of sort of make sense for a 6-inch scope, especially in decent sky position. Right ascension 17, 27, 11, and declination plus 11 degrees, 32 minutes, 33 seconds in the sky's middle third. Very nice. Reconfirming to some degree that we are approximating 6-inch settings for the night under normal 5.5 sky conditions. Now, stabilized, we're now looking for a planetary nebula, and a fairly large one at that. And you know what? I think I do see it right there. Very nice. Kind of like a faint echo of M57, the Ring Nebula. This is NGC 6369. And let me get the data. This would probably be the view of the night, because I love planetaries when they actually reveal themselves as planetaries rather than blurry faint stars. NGC 6369, planetary in Ophiuchus, magnitude 11, 30 by 29 arc seconds, so half of an arc minute in span, apparent size. The central star is 15.1, so forget that. If we were seeing that, then, dude, these settings should be run back if I were actually looking for 6-inch settings. The planetary is 3,600 light years distant, puts it at about twice the distance of the ring. And that would, if it were at the distance of the ring, it'd probably somewhere around 9.5 magnitude, which is about a magnitude fainter, I believe, than the Ring Nebula. The central star in the Ring Nebula is magnitude 14.5. This one's 15.1. And as you know, planetaries are stars that are aging out. They're boomer stars. And they're outgassing a lot of their atmospheric ionization. And we see that with our own sun in terms of coronal mass ejections. But such events would be occurring pretty much over the entire photosphere of an aging star. We're at right ascension 17, 29, 20, declination minus 23, 45, 34, a nice view to catch. Okay, I've initiated camera before we've actually captured this. And right now is when we began actually centering on our study. And the reason I've done that is we are finding a galaxy in Ophiuchus of magnitude 10. So let me give you the data. I have seen 10.6 magnitude galaxies in the eyepiece that are fairly large like this one when the moon was present. So this is a very happy find. NGC 6384. Looking at the screen. Come on, baby, show me. I am not making this galaxy out. Well, NGC 6384, galaxy in Ophiuchus, magnitude, oh, and this may be why. Magnitude 10.4, 5.8 by 3.8 arc minutes. Wow. So we're talking about something that's got an average surface brightness of about 14. And even its core of this spiral with a bar, lowercase bc, wouldn't follow the rule of being 0.8 magnitudes fainter, because actually that core is probably somewhere around 1.5 arc minutes in size. The galaxy is 79 million light years distant. which puts it probably a little larger than our own galaxy, maybe 100,000 light years in diameter. We're at right ascension 1732.24, declination +7, 03, 37, sky's middle third. I am hoping we got some kind of view, and if it is there, it's right about there, and we're only seeing the very core of this galaxy. Anyway, we'll have a look at it mañana. Okay, a little delay in actuating the camera here for another galaxy, but this one's closer than what I expect to be able to see at magnitude 12. Galaxy is NGC 6389. Let me capture the data on that for you. We will be stopping pretty much when we get to 6400 because I think I've captured more than maybe 15 or 20 studies so far. I'm looking at the screen, and we're looking for NGC 6389, Galaxy in Hercules, magnitude 12.1, but fairly large, 2.8 by 1.9 arc minutes, which means an average surface brightness somewhere around 13.5. It's a spiral with a lowercase bc, so 2.5 times removed from lenticular, 142 million light years distant, right ascension 1732.39, declination +1624.07. I wish I could tell you where it is on the screen. I am not at a point where I can see it. Mañana. All right, we're going to go out on some Messiers before we carpe noctem. This is a nebula in Sagittarius, magnitude 5.0. Doesn't look anywhere near as wonderful as it has appeared at the more sensitive and longer time exposures that I typically use, which is 128 flood, 42 decibels, gain 6 passes, color mode with a filter. We are operating at 16 flood, 36 decibels gain. We do have the nebula filter, or the light pollution filter in there. M8, of course, is a nebula in Sagittarius, magnitude 5.0, 45 by 30 arc minutes, 5,200 light years distant. Right ascension 1803.41, declination 2422.49. I do believe we are looking at the Lagoon Nebula. You can see the condensation of reflective and emissive nebulosity here, and the break with this fainter part right there. I probably could center it up better, but that does give you a hint as to what you might see through a 6-inch scope. What we have here is another Messier summertime special. We have not had much in the way of open clusters this evening. This is Messier 11, the wild duck. Open cluster in Scutum, magnitude 5.8, 14 arc minutes in size, 6,000 light years distant. We're at RA 1851.06, declination 0616.0. And I want to point out something to you. In a 6-inch scope, this is typically what you see. You see a lot of these faint stars roughly distributed to almost look like a globular cluster with 1, 2, 3 really brightish stars that capture the attention of the eye. And we are seeing that in Messier 11. And if I were to push this up to the higher sensitivity settings, the contrast between these 3 stars and the rest of the cluster would not nearly be as obvious. Okay, let's watch this. Messier develop. Messier 16. Should be the it should be the Swan Nebula, but it doesn't. No. Oh, maybe that's 17. No, this is Messier 16, Nebula in Serpens, magnitude 6.0, 30 by 40 arc minutes, 7,000 light years distant. I bet you this is probably the Eagle. We're at right ascension 1848, declination minus 1347.0. And we are getting no sense of nebulosity associated with the Eagle Nebula, except maybe a little up here, but I think I've seen something like that throughout the series tonight. So we're just seeing the associated globular cluster, open cluster, sorry about that. Okay, now I think we should be going to the Swan. This will be our Carpe Noctem view of the evening. Messier 17, the Swan Nebula, which is quite apparent and gives a good view in a 6-inch scope on a decent night of seeing. Its swanish nature is quite apparent. You can see the body here, and then the head wraps down to around here. All of that is visible, but in an actual eyepiece scope, you won't notice this texture in here. We are getting some pixelation that's occurring with the way the image is being processed. You wouldn't see pixelation like that. You'd see a continuous flow of nebulosity. Messier 17's in Sagittarius. Its magnitude 6.0, 30 by 30 arc minutes, which means its average surface brightness is probably somewhere around 13. Messier 17 is 5,000 light years distant, has a right ascension of 18, 20, 48, and is fairly south, declination 16, 11, 0, and views at much higher set points are actually quite spectacular, and perhaps we should go out on that if I can appropriately finger the set points. So why don't we step through a few of them. One of the things we'll do initially, let's go to our, no, not that. What I want to do is go to 42. No, wrong direction. All right. So that's 42 decibels, where, as I said, we typically gain about a half a magnitude. I could go to 44.2, but I don't like pushing the CCD sensitivity that high. Still, at 42 decibels, the presence of the Swan is better, but we are getting a lot of unnecessary texture that we wouldn't ordinarily see. So now, if we start stepping through, I'm going to go back down and reduce this to 32 because I want this to develop natively and naturally. By going from 16 to 32, that's a doubling of the flood, and that typically means that you're adding half the aperture to it. So this would be a 9-inch telescope view. So you take 6, you divide it by 2, you get 3, you add 3 to the 6, you get 9, and this is basically how I step through it based on my theory of how sensitivity, shutter speed, and sensitivity interact. So basically now, by going to a 9-inch scope, I believe we have added, let's see, 6-inch scope, 13. I think we've added, we haven't doubled it, so we haven't 1.5. So we've added about 0.8 magnitudes to sensitivity in terms of light gathering. So now we'll stay with the 36 series, and we'll double the 64. Now, 64 is 4 times 16, which means we're basically doubling the aperture, and you can now see the Swan is becoming more apparent with less of the black and white texture and more shades of gray. So here we are, now seeing the Swan through what would be considered a 12-inch scope when at 36 decibels gain. Now if we double to 128, so you take the 12, you divide it in half, you get 6. This would be like an 18-inch scope view. Many very experienced amateur astronomers have their own personal scopes in this range. I have a friend who had a 22-inch at one point. We used to do some very interesting observation at very unique high-altitude locations, got great views. The faintest galaxy we would see through a 22 was about magnitude 15.5, but I've also been to an observatory in Fremont Peak, California, where we had a 30-inch scope. Didn't do much galactic studies, but there was a spectacular view at the eyepiece of Messier 13, and a few other globular clusters. Now we have one more step that we can go, and that's 256 flood. At 256 flood, now basically we have added another half of the 18-inch, which is 9. So this would be like a 27-inch view. Now notice how the screen itself has gotten much brighter. Also notice how much more detail is visible in the swan. But also notice the stars are relatively bloated. There's a good deal of pixelation on the screen, so the aesthetics can be a little more off-putting operating at this. One thing I need to point out, when you operate, when you want to get the best performance out of scope, you operate in deep sky, you operate at 2 millimeters exit pupil. So let's assume this is like 500 millimeter aperture. You would actually be able to operate at 250x, and that would also increase your deep sky reach. But I'm always operating at 75x unless I'm experimenting with this 6-inch scope, which gives me like a 20 arc minute by 15 arc minute field of view, condenses more light down. So effectively, because we're operating at a lower magnification, we are getting a brighter view, but without as much detail. So aesthetically, the eyepiece views are superior, but there's some problems with eyepiece views. Incidental light on the retina from neighboring light sources reduces your sensitivity and detracts from the quality of the view. And observing at the eyepiece requires that you have some skill at properly aligning your retina with the eyepiece, a skill that is easily developed with a little bit of effort. So having said all this, I am going to go back to my normative settings that I normally operate when I explore the NGC catalog of 128 flood, 42, which I consider to be about a 22-inch aperture performance at, in this case, 75x. So we are going to save this, step out, and allow the Swan Nebula and the neighboring stars to come to a little bit better focus before we say Carpe Noctem.